Okay, solve this problem. If both the roots of the equation x square minus 6ax plus 2 minus 2a plus 9a square is equal to 0 exceeds 3, then find all values of a. Press on. Okay, last lecture we have derived three conditions. First was delta greater than equal to 0. Second was minus b by 2a should be greater than k. Third condition was a of f of k should be greater than should be greater than 0. These are the three conditions which we have found out last lecture. If we apply it to this quadratic equation, we will get three solutions. S1, S2 and S3. Finally, we are supposed to take intersection of all three. Discriminant. What is the discriminant? Delta is equal to 36a square minus 8 plus 4a minus 36a square should be greater than equal to 0. This is going to give us solution set number 1. 36 is gone. Therefore, 4a minus 8, which is 4 inside bracket, a minus 2 is greater than equal to 0. And therefore, this is solution set number 1 is a must be greater than 2. Greater than equal to 2.
Sir, it could be 8a, right?
Yes, sir. 8A.
Acha, okay. 8a. So this is 1. This is 1. Therefore, a must be greater than 1. Is that right?
Sir, only instead of 4 there must be 8 in common.
Instead of 4 there must be 8 in common. Okay. Correct. Correct. Okay. This is
Yes.
2 minus b by 2a. K is how much? K is 3. 3 must be less than minus b. Minus, what is b? B is minus 6a. So 6a upon 2. Oh, now this a is not this a. Yeah? This a is coefficient of x, which is 2. Makes it a must be greater than 1. Okay, this is greater than equal to 1. This is equal, and therefore you were reporting a must be greater than 1. But there is one more condition, my dear students. Third condition, a of f of k. Put 3 wherever x is. Multiply by a, which is 1. Okay, so multiplying by 1 does not make any difference. Anyway, it is opening a forward parabola. So 9 minus 18a plus 2 minus 2a plus 9a square should be greater than 0. Makes it 9a square minus 20a plus 11 very simple factorization. 9a minus square minus 9a minus 11a plus 11 should be greater than 0. So 9a inside bracket a minus 1 minus 11 inside bracket a minus 1 should be greater than 0. So 9a minus 11 into a minus should be greater than 0. Okay, so a should be, so if it is leading coefficient is positive, therefore the graph is like this, hollow circles. Now you will realize that this is 1 and this is 11 by 9. So solution set number 3, S3 is minus infinity to 1 union 11 by 9 to plus infinity. Now if you draw 11 by 9 is greater than 1, therefore this is going to be the winner set. So overall solution set answer is open interval 11 by 9 comma plus infinity. अरे समजते का तुम्हाला?
हो सर.
Once you are done with these three, it is purely the calculations that are required to be done and arrive at answer. Next problem. Two. One more problem. S, okay. So I will give you value of k and a quadratic equation. Quadratic equation is 1 plus a x square minus 3ax plus 4a is equal to 0 and k is equal to 1. This is quadratic equation and value of k is equal to 1. Find all values of a. क्या हो गया? Chalo. So same conditions. Only problem you have is coefficient also has got a with it. That is not a big problem. Delta 9a square minus 4 times 4a into 1 plus a should be greater than equal to 0. One condition. Second condition, 3a upon 1 plus a should be greater than 1. Third condition, 1 plus a times 1 plus a x is fortunately 1.
तर अपॉन 2 राहिलं तिथं डिनॉमिनेटर मध्ये सेकंड कंडिशनच्या.
इथे का?
हो सर.
Minus b by 2a, correct. 1 plus a minus 3a plus 4a f of k, a of f of k should be greater than 0. And if you simplify this, then you will end up. I mean, there is, what is there remaining now? Let us check. You want me to solve this? What is this? A cube येतो इथे minus 16.
हो सर. ए क्यूब मध्ये येतो.
A cube कुठे येतो? स्क्वेअर येतो ना?
नाही सॉरी सर.
Minus 16a square minus 16a plus 9a square should be greater than equal to 0. Therefore, now this 7. So 7a square plus 16a should be less than or equal to 0. Therefore, a inside bracket 7a plus 16 should be less than or equal to 0. Now leading coefficient positive, so the graph is like this. This is 0 and 16 by 7 minus 16 by 7 dark circle. This is 0 dark circle and all points in between. This is solution set number 1. Solution set number 2. What is this? Is 3a into 1 plus a upon 1 plus a bracket square. No, first we have to do, wait, 3a upon 2 into 1 plus a minus 1 should be greater than 0. That makes it 3a minus 2 minus 2a upon 2 into 1 plus a should be greater than 0. That makes it a minus 2 upon 2 into a plus 1 should be greater than 0. That makes it a minus 2 into a plus 1 should be greater than 0 by making denominator perfect square. Numerator must be greater than 0. So that graph is like this: minus 1 hollow circle plus 2 hollow circle, and you want greater, therefore all these people and all these people, that is your S2. Okay, and S3, what is S3 saying? How much is this inside bracket? This is a plus 1 into a 2a plus 1 will be greater than 0. So one factor is minus half plus minus 1, minus half minus 1. So this is hollow circle. Minus half is smaller than minus 1. Right. Minus half is greater than minus 1. Therefore, this solution set. So now you have to compare minus 16 by 7 is to the left of minus 1. Therefore, winner solution set is closed interval minus 16 by 7 comma minus 1 open it. This is the solution. Okay, so greater than or now have we found out the condition if both the roots should be less than k? I don't think we have done that.
No, sir, we haven't done.
We have not done that, but I think we should be able to do it quickly. Let us try to do it. Now you should find out, this is called necessary and sufficient conditions for. Find necessary and sufficient conditions for both the roots of ax square plus bx plus c is equal to 0. Find the necessary and sufficient condition for both the roots of ax square plus bx plus c is equal to less than k belonging to R. I give you some time and then we derive it. Okay, we can derive this in more than one ways, algebraically and geometrically, but now we know what are the conditions when k, both the roots should be greater than k. So there will be some similarity in the answer for this question as far as find necessary and sufficient conditions for both the roots to be less than k. So now let us look at it graphically. Suppose you have your real number line and k is here. Both the roots should be less than k. That means now we understand that either this graph or this graph, and when we multiply the given quadratic, so we will not consider this quadratic equation, we will consider a square x square plus abx plus ac is equal to 0, because we know roots of this quadratic equation is same as that of this and leading coefficient is positive. So I need not draw opening downward graphs, only opening upward graphs are okay now, because we just multiplied by a, the leading coefficient. A is leading coefficient. Okay, so this quadratic equation, this is acceptable, this is acceptable geometrically. So from these two graphs we can conclude that x coordinate, that is vertex, x coordinate of vertex, which is minus b by 2a, should be less than k. That is condition number 2. Condition number 1, of course it should have two roots, real roots, delta greater than equal to 0. This is our S1. And now we have to decide about S2. So if we want these two graphs, and these graphs are of a of f of x is equal to 0, then this parabola, or maybe let me draw it. If it is like this, touching x-axis, then what is f of k for this? It is positive. If it is intersecting and going like this, again it is positive. So if you manage vertex to the left of k, both the vertex of the parabola, and still f, because it is opening upward, a of f of k, a of f of k must still continue to remain greater than 0. That is our S3. So if we want both the roots to be less than given value of k, then same conditions except the middle condition is different. Okay, so let us solve this problem. For मी इथे कुठे लिहिलंच नाही की both the, this is for both the roots greater than k. Now find out solution set when both the roots for the same. For same problem, both the roots should be less than 1. Find the solution set for a. Find all values of a such that both the roots are less than 1. So I am trying to. Okay, now we are going to solve the same quadratic equation. Value of k is 1, but this solution set is for both the roots greater than 1. Now find out solution set for all values of a so that both the roots are less than 1. Okay, we have seen that only S2 changes. Okay, so S2 will be all points in between here. Okay, because okay, let me draw S1 again little bigger. Let me draw S2 little bigger. Now minus 16 upon 7. This is our S1. Let us draw S1. Minus 16 upon 7 is less than minus 1. So what are the important points for us? Minus 16 upon 7, minus 1, minus half, 2 and 0. So minus 16 upon 7, say minus half, minus 1, minus half, 0 and 2. These are important points. Okay, and 0 is
Dark circle.
dark circle, all others are hollow circles. Now S1 continues to remain same. So S1, let me mark S1 in red, which is this. Now S2 will be complement of this, and still these circles are going to be hollow. So S2 will look like, let me draw S2. S2 will look like -1, 2 and all points in between. So let me mark S2 by violet. -1 to 2. This is S2. And S3 will be left of -1 up to infinity. So now which color? Green. Left of -1 up to infinity, and right of half up to plus infinity. Is that correct? Is that correct? Are yes or no? This is our S3. So the region where I have red, violet and green. So the answer should be -half to 0. Array, you guys have shown me -half to -1. No.
S3 मध्ये S3 मध्ये आप -1 to -1/2 पण included आहे.
S3 is not changing. S3 is same. S3 solution set is exactly same. I think you are making mistake. All of you together are making mistake.
नाही सर.
अरे S3 म्हणजे ग्रीन आहे.
बरोबर आहे. हेच बरोबर आहे आपण जे केले ते.
मी सांगतोय फायनल सोल्युशन सेट इज -half to 0. 0 inclusive. बरोबर ना?
Yes sir.
Half exclusive. This is the solution set that you should get. तुम्ही बहुतेक S3 उलटा वापरला, त्यामुळे इकडचं काढलं शोधून. नाही तरी पण चुकलं. S3 उलटा लिहिला तुम्ही, बरोबर. मधले पॉइंट लिहिले. S2 फक्त चेंज होणार आहे, बाकी काहीही नाही. Okay. Now we are supposed to do one more problem. Find the necessary and sufficient conditions.
Sir?
Yes. Bolo. Yes. Any doubt? Yes. Any doubt?
So 0.
0 क्या? 0 is.
So 0 should be, I think.
0 should be excluded. Why? In red solution.
It is not the correct one.
In red solution set 0 is there.
Sir, 0 would be there because both the roots would be 0. I checked actually.
Yes. If what is our problem? Our problem, let us put 0. What is our problem? If we put x, if we put a is equal to 0, then it will be x square is equal to 0, x is equal to 0. Both the roots are less than 1. Correct? So 0 has to be there. नहीं समझते? Is it very difficult?
No sir.
Okay. So one more condition we are supposed to solve, which is find the necessary and sufficient condition. 3. Find the necessary and sufficient condition. 56%. for both the roots of ax square plus bx plus c is equal to 0, such that alpha is less than k is less than beta for both the roots alpha comma beta. Now this is going to be critical. K, the given number k should be between alpha and beta. One root should be to the left, one root should be to the right. I give you a few minutes to figure out what is the necessary sufficient condition, else I will show you how to do it. Okay, let us see geometrically. What do we want? We want on x-axis value of k is there somewhere, and as I said, we are not going to discuss this quadratic equation. We will discuss a square x square plus abx plus ac is equal to 0, because as far as roots are concerned, both these quadratic equations have same root. The advantage is this quadratic equation is opening upward. We do not know of the direction of this quadratic equation, whether opening up or opening down, because ambiguity in value of a. But when it is a square, it is definitely positive, therefore it is opening up. So if I want one root which is smaller than k and another root which is greater than k, I am allowed to draw only one kind of graph. That is this, right? I am not allowed to draw any graph like this. Even if at k also it is not acceptable, to the right of k also it is not acceptable. So these three graphs are not acceptable, and therefore your only graph which is available is like this, and then it is very simple. If you evaluate the function at k, it will be negative. So if a of f of k is less than 0, that implies delta is greater than or equal to 0. We need not have to worry about delta, because this is a square. So a of f of k is opening upward.
Sir, delta is strictly greater than 0.
No, not required. You need not have to consider this condition at all, because a of f of k is less than 0 implies delta is greater than 0. Strictly greater than 0 implies. So we need not have to have this condition at all. This condition is more than sufficient. And now, as far as vertex is concerned, that condition is also not required, because if you maintain a of f of k less than 0, of course one root is to the left, another root is to the right. Of course one root is to the left, another root is to the right. Because if you have graph something like this, then a of f of k is greater than 0. Both the roots to the left. If you have graph something like this, a of f of k is greater than 0. Both the roots to the right. So this is the only necessary and sufficient condition. Only one. And therefore problem becomes easy. Solve this question. M minus 1 times x square plus mx minus 5 is equal to 0. Find the necessary and sufficient condition on m. Find all values of m. Such that one root is less than 1, another root is greater than 1. Alpha is less than 1 is less than beta. Let us solve. A of f of k should be less than 0. So m minus 1. First thing that you should note here is that it is a quadratic equation and m minus 1 should not be equal to 0. Implies m is not equal to 1. This is more, very important thing that you need to write. If at all in the solution set, if you end up getting value of m equal to 1, you should remove it because it will never be a quadratic equation in that case. Okay, so the moment we write ax square plus bx plus c is equal to 0, we mean here a is not equal to 0. Okay, so this is one thing which we should remember. And now let us write down a is m minus 1. F of k is, you put x is equal to 1. So into m minus 1 plus m minus 5 should be less than 0. So this is m minus 1 into 2m minus 6, 2 into m minus 3 should be less than 0. So it is simple. Solution set is 1, 2, 3. Done. Arey, samajhte ka? This is a simpler problem compared to earlier. Earlier we have to consider 3 solution sets and take the intersection of them to report the final solution set. Here all the 3 conditions are not there and only one condition is a powerful condition. It takes care of remaining 2 conditions, delta also and vertex also. Vertex we need not worry at all in this case, because if a of f of k is less than, we need not have to worry about where the vertex of that parabola is. One root will be to the left of k, one root will be to the right of k. That is guaranteed. So the necessary and sufficient condition for this kind of problem is only this. This is supportive. If we find out delta is greater than 0, if you put delta is greater than 0, whatever solution set we will get will be part of this solution set. It is going to be, let us check, delta greater than 0, m square minus 4 into m minus 1 into minus 5 should be greater than 0. What does this mean? M square plus 20m minus 20. Correct? Should be greater than 0. So what is this now? What is this condition? Delta greater than 0 gives us what? Solution set. It is going to give us a bigger solution set than this, and therefore this is going to be the winner. So what is the solution set of this? Is this good? No. So m is equal to minus 20 plus minus under root 480 upon 2, which is minus 10 minus 4 भागा लेते 120 root 120 and minus 10 plus root 120. Okay, so these are the 2 values. Opening up parabola greater than 0. So these are the 2 points. This is smaller, minus 10 minus root 120, and this is minus 10 plus root 120. Now root 120 minus 1 minus 10 minus, so this is also a negative number, and therefore your solution set is this. Check, and after this somewhere you have hollow 1, hollow 3. This is the solution set for delta. So delta greater than 0 is definitely going to give you the solution set which is greater than, interval wise greater than the winner solution set. So as far as intersection is concerned, this is going to be the final deciding intersection. Now you see 1 comma 3 is a subset of this solution set of delta greater than 0. Delta strictly greater than 0 will take care of a f of k less than 0 solution set. That is what is the implication. Okay. सगळ्यांना समजतंय? Any doubt? I give you some time to digest what we have done. Find all values of m. For which the roots alpha and beta of the equation mx plus m square 1x plus 16 is equal to 0 satisfy alpha is less than 4 is less than beta.
वो तो इक्वल टू 0 है का कि इक्वल टू u है?
इक्वल टू 0 है, u कुठून आला? Okay, so now k is 4 and a of f of k should be less than 0. So a is m. So m into 14 plus m minus 1 into 4 plus 16. This is a of f of k should be less than 0.
Sir, it should be m into 16.
1 times 4.
16.
And 16 and sir, m square minus 1 times 4. You have written m minus 1.
Yes, sir, m square.
Yes, sir. Now it's
I'm checking whether you are paying attention or not. Okay. Therefore, what is there inside? Inside we have 4m square plus 16m minus 4 plus 12. So I can take out m common, 4 m square plus 4m plus 3. Is that correct?
yes, sir.
Condition. So m, what are the factors of this? m plus 1, m plus 0 and 4 should be less than 0. Wavy curve minus 3, minus 1, 0, none of them dark circles. Enter the graph from bottom, go up like this, like this. Solution set minus infinity to minus 3, open, union, open, minus 1 to 0, open. It is as simple as that. Sketch. y is equal to mod x. Show me the sketch. The graph of y is equal to mod x is going to look like this. X-axis, y-axis. Definition. What is definition of mod x? Mod x is equal to x if x is greater than 0. Is equal to 0 if x is equal to 0. Is equal to opposite of x if x is less than 0. Right? So if x is greater than 0, that means you are putting all values of x on this axis. The value of y is also going to be equal to x. So it is a 45-degree line here. 0, 0. And to the left there. So this is what is the graph of y is equal to mod x. Sketch y is equal to mod x plus 2. You add 2 to each value of y. So if the graph of y is equal to mod x looks like this, then y is equal to mod x plus 2 will look like this. This is 0, 2. Good. Question number 3. Y is equal to mod x minus 1. Sketch. Okay. I started recording now. So this is the graph of y is equal to x minus 1 absolute value. It will pan right by 1. Here it panned up by 2. So when the constant is along x, you flip this sign towards right by 1. When constant is away from x, consider this as same. So up by 2. Now I am giving fourth problem where both the things are happening. So the sketch of fourth problem is going to be like this. Minus 3 is going to be important. And minus 1 is going to be important. So this is the point. And hence, the nature is not going to change. This is minus 1 comma minus 3, like our vertex. If you remember, we have drawn exactly similar kind of graphs for parabola. By making changes with the constants, by playing with the constants. Okay, so now I can have one more variation, which is, say, fifth graph, y is equal to mod x plus 2 mod of mod x plus 2. Okay, next problem is this problem. Anyway, the function mod x plus 2 was positive, and making it further absolute value, this is guaranteed to be non-negative. Therefore, the graph continues to remain like graph number 2. Now, next problem is y is equal to absolute value of x minus 3. Draw this scale. Now, first what you should do is you should eliminate the outer absolute value sign and sketch this graph. It is like this. -3 is here. So 45-degree line, 45-degree line, right? So now this is x is equal to 3. For x is equal to 3, y is equal to 0, correct? For x is equal to -3 also, y is equal to 0, correct? But if x is equal to 1, then if this absolute value sign is not there, then y is -2. But when this absolute value sign is there, y is going to be +2. So for all values between -3 to 3, you will have this gone. And it will get reflected in x-axis. This is going to be your graph of this. Spend good amount of time. Think about it. And now you will play with these variations. But as I said, if I want to solve them algebraically, I need equation of straight line, which we are going to derive very soon. And hence, maybe I will start with 2D geometry, quickly get the equation of straight line and then do this. Next lecture is going to be 2D geometry.